Welcome to how to make an OwlBot, the Bird Intimidator. This is part one of the OwlBot project. The OwlBot will be a device that can be used as a bird intimidation tool to scare away pesky birds or other creatures in your yard, around the house or barn, at restaurants, or in trees, bushes, and gardens. Hence the phrase, the Bird Intimidator. This that you see here is a 16-inch long plastic great horned owl, and we're going to use this plastic owl as the body or structure of our OwlBot project. So that part will be done for us. I found this one on Amazon. These work fine, I suppose, to scare away creatures around your property. You see these quite often when you go to restaurants. I was just at a restaurant the other day and saw a few of these in an attempt to scare away birds from creating nests around the building. But having this plastic owl staring off into space, contemplating its life decisions, isn't quite what I'm looking for as a bird intimidation tool. I needed something that had a little more pizzazz to it, had a little more animation to it, and I figured that, well, I can add a few things to this plastic owl in order to make it a little bit more intimidating to the creatures around the property, in order to try to make it a little bit more effective than just staring at nothing. So what I plan on doing is to add a peer sensor to this plastic owl in order for it to be able to detect motion. And when motion is detected, I want it to make owl sounds through an MP3 player and a couple of speakers. And I also want it to perform various movements. Obviously, this thing is a rigid structure. Its wings are not going to move, its head's not going to move, but we can add a few things to it to help create some movement, and we'll do that later on in other steps in the series of this build. And later on, I also wanted to, of course, I want to add some lights to this thing. So we'll eventually add a couple of red LEDs somewhere around the eyes to have some kind of a red flashing eye effect when motion is detected, to help deter creatures from building their homes or nests around certain areas of the property. So this is what we're going to use as the owl for the OwlBot. And I'm going to put it off to the side here. And you can see in front of you here that I have the items that we will be using for part one of this build for motion sensing. You can see right here in the middle that we have an Arduino Uno, and we're going to use the Arduino to help us control things like this peer sensor that you can see here. And that's all we're working on for part one, is just the motion sensing. So we're going to need this USB cable. This one came with the Arduino. Everybody's seen the types of USB cables that they come with in order to attach the Arduino to the computer to upload the code to the microchip. We'll also need a breadboard. This is an 830-point breadboard. It's preferable to use one of these over a 400-point breadboard like this one. This is a smaller breadboard. We want a little bit bigger because we're going to be adding more items as we move along in the project. We're going to need a 9-volt battery as our power source to power the Arduino. Need a couple of jumper wires. These are male-to-male jumper wires. And need some male-to-female jumper wires for the pins on the peer sensor right here. And in order to connect power, or the 9-volt battery power, we're going to need a 9-volt battery snap connector, and also one of these 12-volt jack adapters that has these screw terminals on it, and that is to be able to install these wires from the 9-volt battery snap connector to the DC adapter here in order to provide power to the Arduino with the 9-volt battery later on. Now, you could use this setup with this adapter and this battery snap connector, or you can use, and these two are what I used in the description and the steps on the website, and what I'll be using through this video series for the build. I'll be using these because these are a little more common, but you can also use a battery snap connector like this with an adapter on the end of it already. So all you'd need to do is just snap your 9-volt battery to this and go ahead and plug it into that. That's easier than using these. I mean, this is not difficult. You just screw the wires into the terminals there. But you can use this option if you'd like. It doesn't really matter. It's up to you. For this project, I'm not going to be using a generic breadboard such as this one. I am going to be using the ultimate DIY 3220-point breadboard that we made in a previous project. And if you have not made this, or you don't have one and would like to make one for yourself, I'll put the links in the description down below in order for you to try out this project. And you can build this. It's not difficult at all. I give a complete set of instructions on our website, and I have a complete video series on how to build this ultimate DIY 3220-point breadboard. But if you don't have one of these, don't worry, you can still use a generic 830-point breadboard such as this one and complete this project just fine. But as I said, I'm going to be using this. It's a little easier. It has a built-in 9-volt battery supply inside this case, and all I need to do is make connections to the binding post here to provide 9-volt power to my breadboard, and flip the switch in order to provide that 9-volt battery power supply to my breadboard. So it's a little easier than making these kind of connections and having to use that. So that's what I'm going to be using. So now I just need to move this stuff out of the way. So now we can go ahead and get started on step 1, connecting 9-volt power to the breadboard. So as I said, I'm using this ultimate DIY 3220-point breadboard. It has the built-in 9-volt battery power supply. That power supply comes from these two terminal or binding posts here. So all I need to do is I need to take a red jumper wire and a black jumper wire and make my connections. These are male to male jumper wires. And I'm going to take my red one and I'm going to make or insert this male end of this end of the jumper wire into the red binding post and tighten that down to secure it in there. And now I'm going to take my black jumper wire and take one end of the jumper wire and insert it into the black binding post. So this is my negative of the supply, the black binding post, and then my positive supply, or my positive 9-volt supply, is this red binding post. So I'm going to take the red jumper wire that I have connected to the red binding post for my 9-volt battery supply, and I'm going to place it into a positive rail for my power rail, my upper power rails up here. I placed it in this positive rail here. So this rail is connected. And now I'm placing the black jumper wire onto the negative rail here. Now it's only connected up to half of these points here, half of the rail. So in order to connect this other half, I'll need to install some jumper wires here later. I can go ahead and do that now. I'm just taking whatever jumper wire I have and I'm connecting that jumper wire across the center section here in order to connect both sides of the positive power supply on the power or on the positive rail there. And I'll take another one. In this case, I'll just take a blue jumper wire and I'll connect the negative rail like so. So now the negative supply rail is connected all the way down, all the way throughout on the negative side. And just to show you, I will hold it up like this so we can see what we got going on so far. So that's step one complete. So if you were using just a generic 830 point breadboard, all you would need to do is have your breadboard set aside and take your 9-volt battery and your battery snap connector. And all you need to do for this step is just install your battery snap connector to your battery like so. That's all you need to do for right now for step one. Moving on to step two, setting up the Arduino for power. So for this step, we need our DC adapter with the screw terminals, and I need 2 jumper wires, a red one and a black one in this case. I'm going to take my, oh by the way, these are also male to male jumper wires. They have the pins on each end. I'm going to take the red one and I'm going to take one end and insert it into the, you can see that there's a positive and a negative label for these 2 different terminals here. I'm going to take my red jumper wire and I'm going to place it inside the positive terminal there, and I'm going to take, I have a flathead screwdriver here. It'll accept flathead or Phillips for for the kind I have here. And then I'm going to just tighten it down. Just snug enough where it's not going to come out of there. So that's the first one. Now I'm going to take the black jumper wire and place one end of it into the negative side, or the negative terminal. And again, just take my, I'm going to take my flathead screwdriver and tighten it down. And that's ready to go. You can see here the black on the negative and the red on the positive. So next, all I need to do is take the other end of the red jumper wire on my DC power adapter here and place it in the positive rail in line with this red jumper wire going to my 9-volt battery supply, or the red binding post here. And I'll take the black jumper wire and place it in the negative power rail that goes to this black jumper wire going to the black binding post for the 9-volt battery power supply here. And that's all we need to do for step 2 for setting up the Arduino for power. Again, if you're using an 830-point breadboard like this and not the ultimate DIY 3220-point breadboard, you have your 9-volt battery and 9-volt battery snap connector installed on the battery already from step 1, and all you would do is take the red and black wire from the battery snap connector and attach it just like we did here. You'd take the red wire and install it on the positive side screw terminal, and then you'd take the black wire and install it on the negative side screw terminal, just as we did here for the jumper wires. So now we're moving on to step 3, setting up 5-volt power for the Arduino. So for this step, we need our Arduino Uno. And again, we need a couple more jumper wires. I have a red and black jumper wire. Again, these are male-to-male ends, or male-to-male jumper wires. What we need to do is take our red jumper wire, take one end of the jumper wire, and we're going to place it into the 5-volt supply of the Arduino. So I'm going to take this and insert it into the 5-volt pin there on the Arduino. And now I'm going to take the black jumper wire and place one end on one of these grounds here. There's 2 different ones. I'm just going to place it into the one next to the 5-volt supply of the Arduino, just like so. And then I'm just going to take the red jumper wire, the other end of the red jumper wire, and I'm going to place it in one of the points on the positive rail here. I'm just choosing to do this far left side here. So I'm using this positive rail here, and I'm going to take the other end of the black jumper wire and I'm going to place it next to the red jumper wire there, but on the negative supply on the power rail here. Again, this side of the power rail, this side of the power rail here is isolated from this side. So again, we'll need to make a couple of connections using jumper wires as we did here in order to connect the full length for both sides of the positive and negative supply on this power rail here on this far left breadboard. So I'm just going to choose, I'll choose another yellow jumper wire here. You can choose whatever color you want, and I'm going to place it onto the positive side, and I will take, all I have is another blue one, another blue jumper wire, and I will place this one on the negative rail. I'll just keep it consistent with this other one here. So I have the blue one on the negative and the yellow one on the positive for this power rail here. So now the negative rail for this power rail here on this breadboard on the left side is completely connected, and the positive power rail here is completely connected all the way throughout. And I will show you a close-up here. That's all we did. We just made the connections there. Let me move these out of the way so you can see better. So now this negative and positive power rail supply here is completely connected throughout. And all I did was place the red on the positive side and the black jumper wire on the negative side, like so, just like that. So now the Arduino is set up for power. We have the 9-volt power supply hooked up and ready to go on this power rail. We have the power set up for the Arduino, the 9-volt power that we'll use when we plug into the Arduino here to power the Arduino. And we've also got our 5-volt supply from the Arduino distributed to the positive and negative power rails on this far left side breadboard here. And we're going to use that 5-volt supply coming from the Arduino for the peer sensor that we will prepare next for step 4. And again, if you're using an 830-point breadboard and your 9-volt battery like this, all you're going to do is you're going to do the same with your jumper wires, the red on the 5-volt, the black on the ground, and instead of on this board, you're just going to connect it to, let's say, the positive and negative supply on the breadboard, just like this. So that's all you would need to do for now. But since I'm using the Ultimate DIY 3220-point breadboard, mine is connected to it, just like that. So now we're at step 4, connecting the peer sensor. So the peer sensor, this is an HCSR 501, and I explain it on the website, how the connections are on this and how it works. What we'll do is we'll remove the Fresnel lens off of the peer sensor so we can clearly see the pins labeled, the pin labels here. We can see the VCC here. That's our positive power. We have an out pin in the middle here, and we have the ground pin on the right side here. So if I flip it over this way, we can see the pins exposed there. And what I'm going to do is I'm going to take a red jumper wire. This is a female or a male to female jumper wire. You can see the female end here and the male end with the pin right here. I'm going to take the female end and I'm going to place it on the VCC pin, like so. Next, I'm going to take a yellow male to female jumper and I'm going to take the female end and install it or insert it onto the out pin. And then I'm going to take the black jumper wire here. It's also a male to female. I'm going to take the female end and I'm going to place it onto the ground pin, like so. As I mentioned previously, I put up a description on these HC SR501 peer sensors, how they work, what the knobs here are for, and what the jumper wire here is for, and other explanations on this type of peer sensor. I'll briefly just discuss it here. This is a peer sensor. Peer stands for passive infrared sensor. Like we said, there's the VCC or positive power pin. We have the out pin, which is the signal pin that will send a signal to the Arduino in this case for our project on when motion is detected. And of course we have our ground pin here. The power pin or VCC pin has a wide range of input voltages. It's anywhere between, I think it's 4 volts and 12 volts. It's recommended that we use 5 volts on it, so that's where our 5 volt source comes from, is from the Arduino that we just hooked up to our breadboard here. So we'll make our connection for 5 volts using the Arduino to the peer sensor, or the peer sensor to the Arduino. The output pin here, the middle pin, it's a 3.3 TTL logic, so it can be used with any microcontroller platform such as the Arduino like we're using here, the Raspberry, PIC microcontroller, ARM, and the 8051. We'll be using, like I said, the Arduino Uno for this project. We also have the ground pin, and of course that allows us for connecting to the ground of the circuit, and this is something we must do. If we turn it over, this little yellow plastic piece here is actually a jumper wire. I don't know if you can see, but there's a little piece of metal here that's connected across these two terminals there. So there's a connection made from a pin here to jump across to a pin here. If I remove it, we can see the pins underneath. So this just makes a jump between those two pins. And I currently have it in the L position. You can see the L right there. There's an L, and there's also an H position right there. That's if the center pin and this pin right there were connected, or the jumper was on those two pins. But like I said, I have it in the L position. The L position, when the jumper wire is in the L position, it locks the high signal to approximately 2 minutes. This is the position that we're going to set for this project. What this means is that when motion is detected, it's set in a single trigger mode, meaning that when something crosses the path of the sensor here, when this Fresnel lens is on, when something crosses the path of the sensor, it triggers it and it locks it to the on or high output position for approximately 2 minutes. So any motion doesn't reset the timer again. It just means that when it's in the L position, when the jumper is in the L position and the peer sensor is working, when something crosses the path, the timer is set to 2 minutes, and no matter if something's crossing that path, that 2 minutes continues to count down, so any motion doesn't reset that time. Now, if we were to set this jumper into the H position, like so, if I were to move the pin to these two jumper wires, now it's in the H position. You can see here the H. You can barely see it, I think, right there. When it's in the H position, this puts the sensor into repeat trigger mode, meaning that when something crosses its path, it triggers the 2 minute countdown, or it begins again. So if something crosses its path again within the 2 minute countdown, the timer will restart the countdown over again for 2 minutes. So any motion resets the 2 minute timer. So in this case, if something crosses the path of the sensor, the 2 minute timer will start, and then if something crosses it again, that 2 minute timer will restart again. So for this project, we're going to keep it in the L position, or single trigger mode, meaning for any motion, we don't want the timer to reset. We just want the motion, the timer to go, and to continue to count down for the full 2 minutes, no matter any other motion comes across it. So now that we have our peer sensor and the jumper wires connected to the peer sensor, now we need to connect the peer sensor to our breadboard. So all we're going to do is we're going to take our red jumper wire, which is connected to the VCC pin, or the positive power pin of the peer sensor. We need to place the other end of that jumper wire to the positive supply, the 5-volt positive supply coming from our Arduino Uno. We need to ground that supply. So we're going to take our black jumper wire that we connected to the ground pin of the peer sensor. I'm going to connect it to the negative of this 5-volt supply here. And then I need to take the yellow jumper wire, which is connected to the out pin of the peer sensor, and we're going to connect it, in this case, to the 12 or pin 12 of the Arduino. Again, if you're not using the ultimate DIY 3220-point breadboard and you're using a generic 830-point breadboard, the next thing that you'll be doing in this process is to, like we did, you had your Arduino set up for power on one end of your supply, or one end of your breadboard, I mean. So yours would look like this. And you had your 9-volt battery, 9-volt battery connected to this, which later will be connecting to the Arduino itself to power the Arduino, but we're not doing that right now. And the next thing, in connecting the peer sensor, you would do pretty much the same as we did with the larger 3220-point board. You take your red jumper wire, place it into the positive supply, take your negative jumper wire, place it into the negative supply, and then take the yellow jumper wire that's coming from the output pin of the peer sensor and just place it into pin 12 of the Arduino. So that's all that you would need to do there. And again, you'd have your 9-volt battery power with the wires connected to the DC adapter, which later, like I said, will plug into the Arduino to power it when we need to do that. But we're not doing that yet. Okay, for the next step of the OwlBot project, for part 1 in motion sensing, we want to go over to the Motbots website for OwlBot part 1 motion sensing, and we want to go down to the programming the Arduino to sense motion section. I'll leave the link in the description below, and all we're going to do is copy this right here. It's going to make a check mark, and we've copied it to our... Okay, now I'm in the Arduino IDE. I have copied the code from the Motbots website. I have my file here named OwlBot Part 1. I'm going to now paste that code I copied, and I'm going to save it. Okay, you can see when I ran the code, I got some errors. It says that there's a stray character or something, and these lines are highlighted here. These are the only 3 lines that are highlighted. After copying the code from the site and pasting it here, the way to fix this is to just backspace these. And if I verify it again, alternatively, to get the code for the OwlBot project part 1, you can go to our GitHub repository called OwlBot Remote and get the code there. All you need to do is just press the copy raw file. And then once you copied that file from our GitHub account, you can come into your Arduino IDE and paste the code into your file, and you can save it there. Okay, for the next part of this part 1 of the OwlBot project, we're going to be programming the Arduino to sense motion. This is going to be the first part of, or the first steps of coding the OwlBot to perform the actions that we want the OwlBot to do. So as I said, for part 1, we are only focusing on the motion sensing part. So we can see here, starting at the top part of the code, we are importing the software serial library. So we need to import the software serial library in order to use the serial communication on other digital pins of the Arduino board. Moving down, we see that we have a couple of variables here. We have the peer variable, which is an int, and we have a motion status variable, which is also an int. We've initialized the peer variable to be the value of 12, and we've initialized the motion status variable to be set to low. So the peer variable will be associated with the signal pin or the output pin from the peer sensor to pin 12 of the Arduino, and the motion status variable is the current motion status or signal pin reading. So the value of 0 is a low reading and the value of 1 is a high reading. The value is initially set to low, meaning initially we don't want this variable showing the peer sensor as reading motion right when the code is compiled. This next variable that we have here is the peer state variable. It's initialized to be low. The peer state variable is the state of the peer sensor signal pin. It's either high or low, and as I said, we initially set it to low because we've set our motion status variable to low initially. So we don't want the peer state telling us that motion is detected when the motion status is initially saying that there's no motion detected. So we go ahead and initialize that to low. And if we look inside the setup here, we can see that we have a pin mode here for our peer variable. That's the pin 12 for the Arduino. So the peer variable was designated as pin 12 on the Arduino. It's set as an output pin because the Arduino will receive input at pin 12 from the peer sensor. So this input to the Arduino from the peer sensor is the 3.3 signal, or the 3.3 volt signal the peer sensor outputs from its output pin when motion is detected. Here we have serial.begin 9600. And what this is that we want to be able to use the serial monitor for debugging purposes. Here we've set it at a typical baud rate value of 9600. And here we've set a delay of 2000 or 2000 milliseconds, which is equivalent to 2 seconds. So we set it at 2 seconds or 2000 milliseconds because we just want to allow the peer sensor and later other modules that we'll be using for the OwlBot project to settle down once things are powered on so that everything's ready to go. So moving down in our code here, we can see our loop. So this is where the code will enter the loop, and the first thing that occurs within the loop is the motion status variable, where we have a digital read, and it's reading the peer signal from the peer or output pin of the peer sensor. So what's happening is that we want to get the motion status from pin 12 of the Arduino, so we just want to know whether that signal is high or low. So as we said, that when motion is detected from the peer sensor, a 3.3 volt signal will occur from the sensor, from the sensor's output pin to pin 12 of the Arduino, and the Arduino will pick up on that voltage signal, telling us that there is motion detected when it's high, or there's no motion detected when that signal is low or at 0 volts. Here we have an if-else statement. Here we're saying that if the motion status is high, so if this motion status is high, or if motion is detected, we want to check whether or not if the peer state is low. And again, we initially set the peer state variable to be low. So right off the bat, when motion is detected, it's going to go into this if statement because that means the motion status is high. And if the peer state is low, which it initially will be because we set it to low initially, then we want to print out to the serial monitor that motion has been detected. And then after that, we want to set the peer state to high because we want to mirror the high signal that's happening from the motion status here. Now, if there is no motion, so if the motion status is low, then it's going to skip this if statement and go to the else statement. So if there is no motion, and if the peer state is high, meaning that it read that there was motion before, but now there's no motion, we want to go inside here and print out no motion detected, and then set the peer state to low to reflect the low signal that the motion status would be currently reading. Okay, once you've copied the code from the website or either our GitHub account, the links will be in the description below. All you need to do is take your USB cable that's plugged into your computer and plug the other end to your Arduino, and then compile and upload that code to the Arduino, and then we'll run the code and then test it by waving our hand in front of the peer sensor. And if everything's working correctly, you should be getting some output readings on the serial monitor showing that there's motion detected or no motion detected printed out to the serial monitor. Once we've plugged in our Arduino to the computer, we want to compile and upload the file by pressing this upload file arrow button at the top left corner of the toolbar. Once that is done, we want to press over here to the far right where it says serial monitor, where we should see printout for no motion detected, and I'm waving my hand in front of the peer sensor. So we can see when there's motion detected and when there's no motion detected. Okay, at this point in part 1 of the OwlBot project, motion sensing, we've connected our 9-volt battery power supply to our breadboard. We've made a connection to the DC power adapter in order to connect to our Arduino, the 9-volt power supply to the Arduino later on in the project. We've connected our peer sensor to the Arduino, and we've connected the Arduino, its 5-volt power supply and ground, to a power rail onto the breadboard. We've also copied the code from the Motbots website. Again, that information and link is down in the description below. If you ran into any problems in the code itself when copying the code directly from the website, there's a great explanation and also video clips there showing how to fix that problem. Alternatively, you could copy the code from our GitHub account at the repository for the OwlBot project. That link is down in the description below. And again, visit our website at motbots.com for this OwlBot project and others in order to find out all the information, how to, and all the steps that you need to know to be able to complete this part of the project at motbots.com. Again, the link is down in the description below. This has been step 1 for the OwlBot project, motion sensing. Next, for part 2 of the OwlBot project, we will be adding sound to our OwlBot prototype. We will be using an MP3 player to store an MP3 file that will contain owl sounds to it, and then we will use the Arduino Uno and add to our code later in order to have that sound play through a couple of speakers that will add to the Arduino and to our prototype here, so that when motion is detected by the peer sensor, those owl sounds will be made. So stay tuned for that part 2 of the OwlBot project. This has been part 1, motion sensing for how to build an OwlBot. Thank you for joining me, and I'll see you on part 2.